Hi, welcome to the Olympiad geometry. Let's continue our study of Simson line theorem. Here is the problem. Three parallel lines through A, B, C intersects circumcircle of triangle ABC on A prime, B prime, and C prime. So you can see AA prime is in parallel with CC prime is in parallel with BB prime. P is any point on circumcircle. PA prime, PB prime, PC prime intersects line BC, CA, AB on DEF, respectively. Prove DEF are collinear. So when we draw the figure, and the first thing that we can feel about is that if DEF are collinear, the line DEF is in parallel with AA prime, BB prime, CC prime. Right, that's a feeling of the figure. So we can just prove DEF are collinear by proving FD is in parallel with AA prime, BB prime, CC prime, and DE is in parallel with BB prime, CC prime, AA prime, right? That's a simple way and very straightforward to think about. So let's look at the figure and try to prove that FD is in parallel with AA prime, BB prime, CC prime. So first thing that we need to look at is how we get the FD, right? So the point D comes from the intersection of segment PA prime and BC. And point F comes from the intersection of segment PC prime and AB. Right? Which means in FD line, right? If we want to find the point D and point F, we don't need this B prime. Right? B prime just help us to find point E, but it's useless here for finding point F and point D. Right? So we can just hide this part, right? Hide the B prime E, all this part. Just think about the PA prime, PC prime, and point D, point F. If we want to prove FD is in parallel with CC prime or AA prime, we need to find some angle equation, right? So it's like if angle PFD equals to angle PC prime C, then FD is in parallel with CC prime, right? So we can try to prove that this angle equals to this angle. We know that AA prime and CC prime are parallel lines that intersect a circumcircle, which means the arc AC equals to arc A prime C prime, right? That means angle ABC equals to angle C prime PA prime, right? So this one equals to this one. Then we know that FBPD is cyclic. So we know that angle PFD equals to angle PBD. Right? Angle PBD is angle PBC. And we know that angle PBC equals to angle PC prime C. So we know FD is in parallel with CC prime. It may feel confusion that how we directly get from this one jump to here. So why solve this problem? The first thing that I'm looking at is that I'm trying to find the relationship between angle PFD and angle PC prime C, right? So PC prime C, that's an angle on the circumcircle of triangle ABC. So I want to translate the angle PFD to be another circle on the circumcircle of triangle ABC, right? So if I know that this angle equals to this angle, then any angle related to this one should be equal to this one, right? It's very straightforward to find another angle that PBC equals to angle PC prime C, right? Then we know that if PBC equals to PFD means PBFD must be a cyclic quadrilateral. Then I need to find another way to just prove that PBFD is a cyclic quadrilateral. Then I can know that angle PBC equals to angle PFD, right? And to prove that PBFD is a cyclic quadrilateral, we can just find another set of angles to be equal, right? So that's why it looks like very straightforward here, but it's not a really straightforward thing. When you first deal with this problem, you need to think it reversely. Okay, now we just prove that FD is in parallel with CC prime. And then we can look at the DE, right? So if we want to prove that DE is also in parallel with AA prime, CC prime, BB prime, right? But point D comes from the connection, the intersection of PA prime and BC, and point E comes from the intersection of PB prime and AC, which means we don't need any information from CC prime, right? So we just can remove this CC prime line out of the thinking, and now we look at this one. So if I want to prove now let me just use a reverse thinking way to do this, right? So we want to prove that DE is in parallel with AA prime. We want to prove this one, right? So if DE is in parallel with AA prime and BB prime, that means we can get angle PB prime B equals to angle PED, right? So if these two lines are in parallel, then we know this angle equals to this angle, right? So we already know that PB prime B is an angle on the circumcircle of triangle ABC. So now we want to find a way that translate angle PED on the circumcircle, right? the PB prime B equals to PCB, right? So if PCB, angle PCB equals to angle PED, that means the angle, that means the PECD would be a cyclic, right? Let me just draw it here, right? So we want to prove that PB prime B equals to PED, right? So if PB prime B equals to PED, and we already know that angle PB prime B equals to angle PCB, right? We already know this. So if this is valid, that means angle PCB equals to angle PED, right? That means PECD is cyclic. Now we just need to find another way to prove that PECD is cyclic, right? PECD. Obviously, it's easy to think about this as this way. So we have the PECD here, right? So if we look at angle DPB prime, always say angle A prime PB prime, right? So this angle, we want to prove that DPEC is a cyclic, right? This angle equals to this angle, right? BCA. So if this is valid, if angle DPB prime equals to angle DCA or BCA, right? That means CPEC is a cyclic. So the angle BCA is reference to the arc AB, right? And the angle A prime PB prime is reference to the arc A prime B prime. We already know that AB arc equals to A prime B prime arc, right? Based on this, we know that angle A prime PB equals to angle BCA, right? Based on this is valid, right? Because AA prime is in parallel with BB prime. So based on this, we know that A prime PB prime equals to angle BCA, which already means that this is valid, right? This is a valid step. And angle DPB prime, that is angle A prime PB. So these two are equal, which means PECD is cyclic. This is true, and because this is true, that angle PCB or PCD equals to angle PED, right? So this is true, and because this is true, that PB prime B, right? Because PB prime B equals to PCB, so PB prime B now equals to PED. This is true, and then we know that D is in parallel with BB prime, and we know DE is in parallel with BB prime, so we know that DE is in parallel with BB prime, and FD is in parallel with BB prime, which means FDE are collinear. right? So this problem is not a very straightforward one, but if you think about it carefully and find the ways that we can prove 3 points are collinear by proving the segment FD and segment DE are in parallel with BB prime, CC prime, A prime, then it's kind of easy to solve. Okay, I hope you like this video and see you in next one. Thank you.